let's discuss another question from theory of machine. Now this time it is from epicyclic gear train. Okay, so we use the tabular method, which basically tabular method of solving epicyclic gear train problem. This is quite an easy stuff. So what we will do is we will first basically so here let me just write down the components first. So first we will be considering the arm, and which is I think 4, the number 4, and then the sun gear, which is 2, and this is as per the number given, and then the planet gear, which is 3, and then the ring gear, which is 5. Okay, so first we fix the arm and we don't provide any rotation to the arm, and now we give in the clockwise rotation only, we give x rotations, or I mean you can give one rotation and then effectively you have to multiply everything with x. So we give x rotation to the sun gear. So basically the sun gear rotates in a clockwise direction with x, and remember that arm is fixed in the first step. So when arm is fixed, so this is just when 2 rotates about its center in a clockwise direction with the amount of rotation x, 3 will rotate in anti-clockwise about its center only. It doesn't rotate about the sun center at this point because arm is fixed. So it's just 2 gears with their axis fixed, and because 2 is rotating clockwise, 3 rotates anti-clockwise. So how do you find out the planet rotation? Now for this you need to understand that your n1 t1 is equal to n2 t2 for 2 gears with their axis fixed, and when one is rotating, the amount of when one is rotating with speed n1, the speed n2 can be found out by this formula. Now this is simple. I mean even if you forget this, is easy to obtain because at the interface your r omega is constant, right? So when your r omega is constant, but r is module times, basically module times number of teeth. So basically teeth into omega is constant because module is again a constant for a pair of gear, and t and omega is constant. Omega is we can express in terms of n, so ultimately it comes tn is equal to constant for a pair of gears which are in mesh. So that's what n1 t2. So now applying same thing for sun and planet, we get for the planet n2 we get n1 t1 by t2. So n1 is basically the number of teeth on the sun gear, which is 20. X is the revolution of the sun gear by number of teeth on the planet, which is 40, and I put minus because this rotates in anti-clockwise direction. We consider sun gear to be clockwise, so planet gear will be rotating anti-clockwise. And now the ring gear, because the planet gear rotates in anti-clockwise, the ring gear also rotates in anti-clockwise because it has internal teeth. Now imagine that 3 is rotating anti-clockwise, it will take 5 also to be rotating in anti-clockwise, right? Because there is an internal mesh, it's not external meshing of teeth. So applying the same concept n1 t1 by t2, now we have this is the speed of the planet. So multiplying now with the number of teeth of the planet, which is nothing but 40, dividing the entire thing, and this is n1 t1 dividing by the number of teeth on the ring gear, which is 100. So solving this, ultimately we get this as x, this is x, this is minus x by 2. I mean you can write, I'm just simplifying facts here, and this becomes minus x by 5. Okay, so now, so this is basically effectively, I mean the same step. Okay, now when I give rotation to the arm, the entire arm rotates with y, so it takes so adding everywhere y, So the total set of revolutions will be, the sun gear is x plus y, and this is y minus x by 2, and this is y minus x by 5. Okay, so what we have done is basically, effectively this tabular method does is that it splits the problem in two ways. First is in the step 1, which is assume that arm is not rotating and then everything is at their own place. The sun rotates about its center, the planet rotates about its center, and then ring gear about its center. Then we add the arm rotation to every component, and then we get the total rotation. And now what is given is that the ring gear is fixed, so basically y minus x by 5, which is the rotation of the ring gear, so this is 0. And the other condition that is given is that the gear 5, okay, the gear 2, which is nothing but the sun gear, is 60 rpm counterclockwise. Okay, so x plus y is 60 rpm. Okay, so here, I mean, we have assumed everything to be clockwise, but based on the data given, the gear 2 is rotating 60 counterclockwise. So even if you assume that everything is rotating anti-clockwise, the same principle will hold, right? So assuming that x is counterclockwise, and so planet gear will be clockwise, the ring gear will be clockwise, and so basically plus will be for counterclockwise and minus will be for clockwise. So this is, again, at the start you should make this. I mean, it doesn't matter whether you take counterclockwise to be positive and counterclockwise to be negative. Ultimately everything will boil down to the same thing. But at the start, whatever you fix, you need to follow it throughout the end of the problem. That is the condition. So here we assume that the positive rotation is for counterclockwise, the negative rotation is for clockwise. Okay, so y minus x is 5. So solving these two, we get y is equal to 5y is equal to x, and so 6x is 60. So 6, substituting that in the second equation, we get 6x is 60, x is 10. So x we get it as 10. Oh, sorry. I think 6y is 60. Y we get it as 10 because we substitute in the place of x 5y, so it becomes 6y 10. So y 10. And remember that it's 10 rpm counterclockwise direction because we assume that positive to be, yeah. So 10 rpm counterclockwise is the rotation of the arm, and that is what is asked. The arm attached will rotate it. So 10 rpm. So this is an easy method, the tabular method. You have to just basically use your tabular method. You have to split the problem and solve it. So this is the way to solve it. Most of the time, because there are two variables y and h to be formed, so there will be two equations given here. About the ring gear, it is fixed given the problem, and the speed of the shunt gear is given. So you have to just basically use these two conditions to solve the problem. Thank you.